let's look at some examples of the while loop. As you can see here in my development environment, I have a while loop set up and ready to go. I have created a variable named counter and initialized it to 0. And then for my while loop, I have while counter is less than or equal to 5. So this is my condition. And as long as this condition evaluates to true, the code that is indented underneath of it will execute. And I have print counter, and then I'm incrementing counter by 1. And if I run this, we'll see that I get the output 0, 1, 2, 3, 4, 5. If I instead wanted to do something like only print counter when counter was even, I could do this by introducing an if conditional and using the continue keyword. So down below my loop, I will put if counter mod 2 is equal to 0, which is the case when counter is an even number. Then print counter and continue. And I will remove this print counter line here. And now when I run this, I'm actually going to have a problem. It is going to just continuously print out tons and tons of zeros and never stop. So I'm going to hit Control C to stop this in Visual Studio Code. And the reason being is that this continue keyword right here immediately ends the current iteration and forces it to the next iteration, which means this line of code right here to increment my counter never executes, so my counter never gets above 0. So if you use the continue keyword, make sure that you do something to change your conditional before the continue keyword, or you could end up in an infinite loop. So I'm going to put counter plus equals 1 here. And when I run this again, we get the output 0, 2, 4 like I expected. And if I wanted to execute some code after this while loop finished, below the while loop, I would put in the else statement, and then indented underneath that, I would put whatever code it is that I wanted to run. In this case, I'm just going to tell it to print the word done. So when I run this now, I get 0, 2, 4 and done. Now let's say that there's a condition where I didn't really expect it to happen, but it's happened, and because it's happened, I want to immediately get out of this while loop. So if I were to change this to say if counter is equal to 3, for whatever reason I didn't expect counter to become 3, and I immediately want to break out if it does happen. Below that, I would simply type in the break keyword, and I'm going to put my print counter down here. That it actually prints it out. And now when I run this, we'll see that I get 0, 1, 2, 3 doesn't execute because it breaks out of the while loop before the code down here runs. But you'll notice that it also doesn't run this code here that says print done. And this is because when you use the break keyword, any else clauses will not execute. Another way you could use a while loop is simply by typing while true. And then if I were to do something like print high down here and run this, it's just going to print high forever because there is no way for true to ever become false, and there's nothing in the while loop to actually break it out. So if I hit Control C to end that, I can put something up here that will provide a condition to break out of this while loop. So I could put something up here like if input, and then prompt the user to enter Q to exit, and then have it actually check to see if the value that was entered is in fact Q, and then I could break. Now when I run this, it's just going to continuously prompt the user to enter Q to exit, and while they don't enter Q, so if I enter W, it's going to keep running. If I enter E, it's going to keep running. If I enter R, it's going to keep running. But as soon as I enter Q, it exits the program. However, using a while loop like this is a little risky because you introduce the possibility of ending up in an infinite loop that never breaks out. So make sure that if you do use a while loop like this, that you have a very clear way to break out of that loop. And the last thing that we will look at for while loops is using nesting. You can actually put a while loop inside of another while loop. Although this isn't common for while loops, it is more common for loops, but I will show you how to do that. I'm going to change this variable to be num1 and initialize it to 1. And then I will put while num1 is less than 4. And then underneath that, I'm going to initialize a second variable called num2 and initialize it to 1. And then under that, I'm going to create a second while loop and say while num2 is less than 4. And then for this while loop, I am going to tell it to print num1 times num2. And then I want to make sure that I increment my value. so that this condition can be evaluated properly. So I'm going to increment num2 by 1. And then outside of this while loop, so I have to make sure I have my indentation correct, I am going to increment num1. And now when I run this, this while loop is going to execute first with num1 equaling 1. And then it's going to initialize num2 to equal 1. And then it's going to say while num2 is less than 4, print num1 times num2. So this is going to be 1 times 1, 1 times 2, 1 times 3. And then when this while loop increments to its next iteration, num1 will now be 2. So when this one runs, it's going to be 2 times 1, 2 times 2, 2 times 3, etc. until it gets through all of them. And if I run this, we'll see that I get the output 1, 2, 3, 2, 4, 6, 3, 6, 9. And like I said, nesting with while loops is not very common because it's a little convoluted, a little clunky. It's a lot more common in for loops, and we will see that in an upcoming video.